For today's lesson, we are going to learn about logarithms, and this is something that should be completely new for you. And it's dealing with kind of a different form of our exponents that we work with. So if we look at these explore problems here, we have 1, 2, 3, and 4. And you'll notice that with all of these, we have the variable, the unknown, is our exponent. Okay. So for problem 1, we have 3 to the x power equals 9. And we are solving for x by kind of answering the question, hey, what power does 3 need to be raised to in order to get 9? And if we do this, we would know that if I do 3 times 3, that would give us 9. And so in that case, my x would have to be equal to 2. 3 to the second power equals 9. So think through the rest of these 3 problems. Try them on your own, and then pause your screen, come back, and make sure that you can justify your answers, either in writing or out loud. So if I move on to problem 2, I think about, all right, how many times do I need to multiply 2 by itself to get 8? Or what power do I need? I need 2 times 2 gives me 4. So I need to go with another 2 to give me 8. So in this case, x is equal to 3. Similarly, x would be equal to 3 down in problem number 3. I would have to go 10 times 10 would get me to 100, times another 10 to get to 1,000. So x would equal 3 there. And problem number 4, we know it's got to be greater than 3 based on our last one. So 2 times 2 times 2 gets me to 8, times another 2 gets me to 16. And finally, another 2 to get me to 5. So x would have to be equal to 5. So we are learning about a logarithm today. And so let's get a key definition down for it, describing what a logarithm is. And then in your table on your note sheet, get the kind of definitions of exponential and logarithmic form written down. But basically, a logarithm is the exponent or power to which a base must be raised to yield a given number. Basically, when we're calculating logarithms, we are going through that question. What power do we need for a given equation? So if you look down here at exponential form, we have a base, an exponent, and what we're going to call an argument. All right, b to the x power equals n. Similar to how, hey, 2 to the third power would equal 8. Okay, 2 is our base, 3 is our exponent, 8 is the argument. Well, we can rewrite this in a different way called logarithmic form. And we would have log with the base as a smaller subscript b. The argument would go inside our parentheses for log, and then it would be equal to our exponent. So the answer to a logarithm is the exponent. So if I were to take this equation here and rewrite it in logarithmic form, it would look like log base 2 of 8 equals 3. So let's try rewriting a couple of these from exponential form into logarithmic form. So now we're going to fill out example 1, 2, 3, 4 in our table to make sure we got a good understanding of how to jump back and forth here. So example 1, 5 to the third power equals 125. If I were to rewrite that in logarithmic form, I would have log base 5 of 125 equals 3. And you can see here that, hey, our base number 5 goes down and becomes the base in our logarithm. Our argument, 125, goes inside our logarithm here. And finally, our exponent is what the logarithm is equal to. So try this next one on your own. Pause your screen, unpause it when you're ready to go. M to the n power equals p. That will be log base of m of p equals n. Similarly, we can go the other direction. If I give you logarithmic form, we can go back to exponential form. So if I have log base 2 of 8 equals 3, like I do in example 3 here, I'm going to have 2 to the third power equals 8. And if I have log base of x of z equals y, I'm going to have x to the y power equals z. Make sure that's clearly a z there. So the other skill we want to practice today, outside of just jumping back and forth between exponential form and logarithmic form, is actually evaluating these logarithms. So figuring out what power we need to solve these logarithms. If we have log base 3 of 9, all right, we want to think about, all right, what power do I need to raise 3 to in order to get 9? One tip that I have is to rewrite an exponential form possibly. So if I have exponential form is 3 to the something power, let's call it x, is equal to 9, then I'm answering that what power question. All right, so x would have to be the power of 2 there, so the log base 3 of 9 is equal to 2. Okay, let's repeat this process for examples 6 and 7. Go ahead and pause your screen, try this on your own if you need to, then come back and I'll explain it. So I have the base of 4 taking the log of 64. If I want to rewrite that in exponential form to help me solve the problem, I would have 4 raised to the x power equals 64. In this case, that would have to be 4 times 4, give me 16 times another 4 would get me to 64. So I would need to have to the third power. And let's try it with this last one, log base 2 of 64, exponential form here. If I rewrote it, I would have 2 to the x power equals 64. Now we need to go 2 times 2 gives me 4, times another 2 gives me 8, times another 2 gives me 16, times another 2 gives me 32, and finally the last 2 would get me to 64, so I got 1, 2, 3, 4, 5, 6. My logarithm would be equal to 6.